Hello, everyone, and welcome to Path to Power, P2P. In this video, I will talk about how to define the environmental condition and how to define your basis, the hazard intensity threshold in FAST consequence. It varies from one company to another company, the level of thresholds, minimum and maximum, when it comes to the thermal radiation, isoblitz from the dispersion, and the overpressure from explosion. So the first item, environmental condition. Here we have weather tab. By default, you will see three categories. In each category, you have a specific wind speed and the stability factor. And the stability factor, it depends on the guideline and the preference in your operating company to be applied. For more explanation about each type and the meaning of it, when you go to the help, it will explain here these stability, wind speed, and the description of each and every one. So it is very high level good guidance how to use the stability factor. So in why we have three, it could be based on the wind rows. You have potential wind speed, majority during the seasonal variation in the year, you have various wind speed, and there are some wind speed with a small contribution. It's worthwhile in some cases to include the less frequent wind speed. This is why you have variety of adding various environmental data set to be examined. If you have 5, every time you will run the consequence model, you will have 5 isoblitz for each wind speed. I can delete this for simplicity. For my demonstration, I will keep it 1 and will consider 3 meters per second and D stability. 3D. Going to a parameter, it is very, very important. Starting from the pool fire, we have various levels. We call it the hazard intensity threshold. Starting from level 1, 4 kilowatts per meter square. If you need to calculate the probability of fatality, you can take this, and here 0.01, it means 1% as a probability of fatality lethality level. Could result from 4 kilowatt meter square, which means if you have a specific leak, liquid leak or hydrocarbon leak, and it results in 4 kilowatt meter square specific contour. If you have 100 people within this area of impact, 1% from the POP will die. So if you have 100 people, it means 1 people will die as a lethality level. So it is really important to identify and to let FAST to calculate the lethality. This will help you to determine the number of fatality, and based on that, severity will be calculated and determined based on the risk scoring. And I will do the same for 12.5. I will give it 0.5, which means 50% as a probability of fatality, 37.5, 99% probability of fatality, and then I will hit OK. And I will do the same for the jet fire. I will calculate lethal fatality for the mid-level. Highly likely it is 50%. Again, it depends on the company operating procedures HSE guideline. Fireball, same. Explosion, it depends on the impact on the human and impact on the building. You will define this. Very important, if you have a source of ignition, whenever you have unignited release, hydrocarbon dispersion, once the hydrocarbon dispersion will pass through source of ignition, it will make an explosion. Based on your plot plan and layout, you can determine the distance for that explosion, and from the explosion parameter. So most of the things now, it is determined parameters to reflect the company's guideline and technical standard, in addition to the weather. Now I can rerun this scenario. I can go home by selecting the scenario. I will run. PHAST will regenerate the outdated contours from the previous. Go to graphs. It will generate. So this is the side view at this concentration. If I have a specific concentration of interest from consequence as explained from the previous video, I will go to the concentration. I can untick these things. If this is my concentration of interest, eventually I will have one contour. For the jet fire, these are the levels. I have 4 kilowatts and a 12.5 lethality. It tells you have a lethality only 1%. Within this circle, you only have 1% as a lethality. So if you have 100 people, as explained, only one person is subject to immediate fatality. Explosion, based on that release and hydrocarbon and the release and leak rate, the model didn't see any significant consequence from the explosion and overpressure for that scenario. So I hope from this video the weather definition and parameters definition and the HIT definition is clear. Until then, see you soon.